So differentiation and integration questions. Any doubts?
No, not really, sir, at the moment. Actually, yes, just general one. In question two. Um, I'll tell you which exercise. Just 1 minute. Um, so in those pictures that I sent, exercise E.6.1.
Right.
Questions two B. Question 2B.
Okay, let's take a look. This is the E.6 point.
1.
Yeah, question number.
Question number. Just give me a second, sir. Question question 3B, 3A and B.
3A and B. Let's see. So 3A is integral of cube root of x square dx. You can rewrite this as x to the power 2 by 3, which would then become 5 by 3 on 5 by 3 plus c. Right?
Yes.
Okay, B part, same logic. So cube root and then it is power 4. So first you'll write it like this: x to the power 1 by 3 whole power 4. So we'll then make it x to the power 4 by 3, which would then give you x to the power 7 by 3 upon 7 by 3 plus c. Right?
Yes, sir.
Okay. What else?
So I was just confused with this and F part. So F.
Image is not very clear.
Yeah, I'll share the image. Just 1 minute.
You could just tell me what roots are these.
All right. So it's. I'll just share the image. So just 1 minute.
Right.
I've sent it. So it's 5 and 3.
Checking. Yeah, 5 and 3. Very sharp images. Okay, so along similar lines, firstly, distributive rule, you can write this as integral of fifth power of x dx minus integral of third root of x dx. And then it's quite straightforward.
Six to the power 5. Yes, sir. Understood. So, okay. So maybe we could move on to like boundary conditions now, because that's what it says after substitution.
Yes, we can do that. So boundary conditions, if you remember, we did do it actually. Boundary conditions is when you have an indefinite integral and they give you some value of f at some x, hence you find the constant. You remember doing that?
Yes, sir.
So how about you send me the photos again
Okay.
of that particular exercise and let's do that together.
Of the boundary conditions one, sir.
Exercise, yeah, exactly.
I'll just do that. Yeah. Just 1 minute, sir. And I sent him, sir.
Right. Let's start with the first one. F prime x is given, and it is also given that the curve passes through the point 1, 5. How could you find fx here? Any idea?
By integrating.
Yeah, firstly, you can integrate. So what would be the integral? Fx equal to integral of 2x plus 1 dx. Let's first try that.
X square
Write yourself.
plus
Mhm.
X.
Yeah, x square plus x. Absolutely. Plus c.
Plus.
And how do you propose to find c here?
When we're given limits, so then we can find C. No,
लिमिट के बिना
लिमिट के बिना if we're given I don't know. So if we're given one value of y and we're given two values of x.
they have given one value of y corresponding to one value of x, right?
Yeah.
So what is that value that they have given? Take a look at that. They have said that the curve passes through 1 and 5. That means, what that means is x is 1 and y, which is f, is 5 at that point.
Yeah.
They have said that f1 is 5.
So C is 3. Yeah.
Mm-hmm.
3. Yeah.
C is 3 is correct. So we can conclude that fx is equal to x square plus x plus 3. That's how it will work.
Yeah.
You follow?
Yes, sir.
Okay,
Yes.
let's move. Move on to the next one. There they have made it directly clear. So can you try that one yourself?
Yes, sir. Okay. So I'm getting C equal to 1.
Let's check that out. Yeah, that's correct. Let's move to the next question. Two x minus x cubed by 3 plus c is 7.
Yeah.
C part. Yeah, same kind of question.
Yes, I'm doing that question.
Mhm, mhm.
So I'm getting minus 5.04.
Let's check. C is 5.04.
Yeah, yes, sir.
Uh,
Oh, oh, oh. Oh, okay. Mhm.
so that's what I got.
So just give me okay. I accidentally I took the y and x values from D part accidentally. So I'll make
That's
it.
all right.
Understood, sir.
Right. Okay, let's go for the next one.
Minus.
All right, how far have we got here?
Sir, how would we do part E?
Sure. Let's see. So if you were to find y, right, this integral needs to be evaluated. So the constant goes out and you are left with x plus 2 whole square dx. This is of the form of integral of ax plus b dx, which will give you ax plus b whole square by 2, and then a comes out. Here a is 1. So this will simply become x plus 2 whole cube by 3 plus c, right?
Yes.
And then you just plug in the values, 8 and 0. We'll be left with 8 into 8 by 3 plus c. So c turns out to be 0, which means y is simply x plus 2 whole cube.
X. Okay. Yeah. X cube. X to the power 1 by 3. Mhm. Okay. So for F part, I'm getting C equal to 0.
Yep.
So for G part, I'm getting C equals to 2.
Let's see. What C did you get?
Um, See, I got is 2. What have I done wrong? So what I did was I saw that it was in the AX plus B form. So I did x plus 1 uh, square upon 2, x minus 1 square upon 2 plus
This is not AX plus B form. I mean, X plus 1 is and X minus 1 is, but they are multiplied.
so, so,
So
so
either
how
you
do we
apply the product rule,
okay.
which is we haven't studied yet, and either or you could just apply the identity A plus B into A minus B is A square minus B square. That is open the bracket
Yeah.
and then solve.
Yeah.
That's what I did.
Understood. So there's that product rule, what you were saying.
We haven't studied it. It's probably not even there in your syllabus, so it's not required at this stage.
Yeah.
Like there is a product rule in differentiation, right?
Yes, sir.
Same holds true, but a more difficult formula for integral will get there when required.
Yes. So I'm getting C equal to 3 for this.
Let's see. Yeah, that's correct. You can go ahead.
So how would we approach question 2?
Yeah, good question. So they have given dual boundary conditions, you can see, and they have given a third boundary condition indirectly. So there will be three variables, variable A, variable B, and when you integrate, you'll have a variable C. So let's first find fx, ax squared by 2 plus minus b by x plus c. Now can you see there are three variables here?
Yes.
And there are three conditions. What are the three conditions? First condition, they have given f prime 1 is 0. So I can say that f prime 1 is 0. Alrighty, I'll just say that 0 equals a plus b. That's my first equation. What is the other equation they gave? f1 is 4. That means f1 is equal to 4, or I could say that 4 is equal to a by 2 minus b plus c. That's my second equation. And last thing they said that it also passes to the point minus 1, 2. So indirectly they are saying that f of minus 1 is 2. So I could say that 2 is equal to equation number 3. How many variables and how many equations?
Three variables, three equations.
So are we good to go?
So I have one question.
Yeah.
How did you get plus brackets minus b upon x?
Yeah. If I integrate b by x squared dx, this is b integral x to the power minus 2 dx, b x minus 1 by minus 1.
Understood.
Right. So now you just have to solve these three equations. I would recommend subtracting 3 from 2 first.
equals plus C. B equals B minus 1. B is equal to minus 1. A equal to 1. So I got A equal to 1, B equal to minus 1, and C equal to 2.5.
Let's see. Is this correct?
Um,
I think it's the other way around.
yeah,
B is minus 1 and A is plus 1.
yeah. Um, 2.5.
3.5.
3.5, sir.
Yeah, correct. Is that what we got?
Yeah, I got 2.5, but I see where I gone wrong. I got I got A and B correct. C, I've seen one wrong.
Right.
Question. So we'll first integrate, will we integrate CX or will we leave it as that?
Yeah, you have to integrate C prime. And then see, here is the indirectly how they are telling you. They're saying cost per unit and X is the unit.
Yeah.
So that means cost per unit is C1 is equal to $40.
Oh.
Yeah, like, so it's a little twisted here. It's fun doing these kind of questions, isn't it? So cost per unit, we know how to solve, but
Yeah.
then we have to identify cost per unit. C1 is 40. So now things become simple. That means I can say 40 is equal to 30 minus 0.06 by 2 plus C. That will give me C equal to 10 plus 0.03. So that's 10.03. Now CX becomes and the final answer 150. So you can substitute the value of X to find for 150.
So we'll just how much?
Stop now.
Okay.
No, we'll do this question then we'll stop.
TX. So
Better use a calculator for this one.
yeah. Yeah. So I got 3835.03.
That is correct. Not 0.0. Yeah, correct. All right, Mike, we can stop here.
Yes, sir.
And for homework, you can carry on with the exercise,
I'll do.
whatever is left in it, and we'll continue with the next topic in the next class. Yeah.
Yes, sir.
All right. See you in the next one.
See you, sir. Thank you.
Bye bye.